Hi students, this is Sivakumar, 11th standard mathematics, chapter number 1, continuation of exercise 1.2. Now problem number 1, subdivision number 2. Let P denote the set of all straight lines in a plane. The relation R is defined by L is related with M if L is perpendicular to M. This is the given statement. The L is perpendicular to M. Here P refers set of all straight lines in a plane. Okay. Here I have written the question. Let P denote the set of all straight lines in a plane. The relation R is defined by L is related with M if L is perpendicular to M. Solution. P, that is set of all straight lines in a plane. Okay. Now we start with reflexive. For reflexive, first you have to write statement followed by relation. This is a procedure, statement followed by relation. In this problem, the statement is L is perpendicular to M. Here L is perpendicular to L only have to consider. For reflexive, both should be same always according to the definition of reflexive. A is related to A. Here L is perpendicular to L. Here a line is perpendicular to that same line? No chance at all. So what I have tried? L is not perpendicular to L. Therefore, L is not related to L according to that question. So because what is given, look at the statement. L is perpendicular to M. That is the statement. This statement is true only how to put or. If the statement is wrong, that or has to be striked out, remember. So here a line is definitely not perpendicular to the same line. No chance at all. So that you have to put L is not related to L. So or is not reflexive. Now we can go for symmetric. First relation, then statement, again statement, finally you have tried the relation. Already told you this is a procedure for symmetric as well as transitive. Relation, statement, statement, relation. Here relation, I take L and M. L is related to M. That is a relation. This can be written in statement form. L is perpendicular to the line M. For your reference, I draw a line over here. L, M. L is perpendicular to M. Obviously, M is perpendicular to L also. Correct only, no? L is perpendicular to M means definitely the line M is also perpendicular to L. So L is perpendicular to M. The symmetry is, the reverse is M is also perpendicular to L. So M is perpendicular to L means the condition is true. The given statement is true. Therefore, you can write M is related to L. Therefore, L is related to M. We start with L is related to M. We have proved M is related to L. That is called symmetric or is symmetric. Now the last one is transitive. Transitive. For transitive, same procedure, relation, statement, again statement, finally relation. Okay. For relation, here you have to consider three lines. L is related to M. Here ends with M. So you have to consider M is related to some other line I consider as N. Here ends with M, here starts with M, continuity is there. Here the starting one is L and ending one is N. We have to verify L is perpendicular to N. We can verify, right? First we can write the statement for this relation. L is related to M. According to this problem, L is perpendicular to M. This is a symbol for perpendicular, you know that. And M is related to N. According to this problem, M is perpendicular to N. Okay. First we can verify. Here I take L. Here I take M. Okay, M. Here L is perpendicular to M. Now I am going to draw one more line that is perpendicular to M. Okay, listen. L is perpendicular to M. L is perpendicular to M, correct? M is perpendicular to N. This is M, correct? M is perpendicular to N. Now look at the two lines L and N. Here L and N are parallel. It's not visible. Again I tell you, please. L is perpendicular to M. Have drawn. Okay. Next, M is perpendicular to N. Now look at that. L and N are parallel. These two are parallel. So what I have tried here. So combined together, L is not perpendicular to N. We are not supposed to write parallel. The word has to be the same. What's the statement given? Perpendicular only given. So you have to write not perpendicular only. Not perpendicular, that means parallel only. But don't write parallel. So what I have tried? L is not perpendicular to N. Now you can write the relation. The relation is L is not related to N because the given statement is false. The given statement is perpendicular, but what we have proved not perpendicular means that is not relative. So L is not related with N. So it is not transitive. Finally, write the result or is not transitive. So subdivision number 2 is completed. I'll be teaching the next subdivision, that is subdivision number 3, in the next video. Thank you, children.